Excellent. So in today's lecture, I want to continue our discussions on data management techniques and strategies in Unit 2 with the collections framework and generics. And so I believe last lecture we were discussing queues and stacks. So I want to continue our exploration with a priority queue, which is going to be a very particular style of queue that you'll see as we explore through this slide deck. But just like sets and maps had a sense of maintaining a sorted order with a tree map and a tree set, we can actually have a concept of a sorted queue with what's called a priority queue. And so just a quick overview for what we'll be talking about, introduction into priority queues, some real world examples of a priority queue. We'll look at the hierarchy of priority queue as it is in Java, the class declaration, the features, the constructors, the methods, and some example code. So quick introduction, a priority queue in Java is a collection or collection of elements. Is a queue or a collection of elements in which elements are stored in the order of their priority. So recall that one of the definitions of a list, for instance, one of the very first data structures we're looking at is that order order is preserved, but it's usually in insertion order, right? So here we can start talking about ordering things based off of a ordering pattern that we get to define, something outside of insertion order. So it is an abstract data type similar to any ordinary queue except for its removal algorithm. So an ordinary queue is first in, first out data structure. And so in a FIFO, elements are added to the end of the queue and they're removed from the beginning. So in a priority queue, elements are stored in the order of their priority. So when accessing elements, it's those elements with the highest priority that are going to be removed first. And then you continue that sequence until you get to the lowest priority. And so again, the priority queue is already defined and implemented for us like the rest of the collections we've looked at inside of Java. Priority queues were added in Java 5 as part of the Java collection framework. So that's going to be the util pack, java.util.PriorityQueue. So some real world examples. Think of a typical example of a priority queue as, say, for instance, a work schedule, like a maintenance schedule. So works are added into a random order, say, for instance, at an apartment complex, but each work has a priority associated with it. And the urgent work orders are going to be assigned the highest priority and done first before the less important ones. Another example you might see a priority queue in the real world would be at a hospital. So the emergency room might assign a priority number to a patient for each patient inside of the emergency room, and the patient with the highest priority will get checked up first all the way down to the lowest priority. So similarly, Java priority queue class provides an implementation of a priority queue for the instances where you want to be able to go ahead and throw in data but have a different priority ranking on what should get extracted out first. So we're going to take a look at a little deeper look at that. We can create a queue with its own priority queue. Okay, so priority is decided inside of the Java implementation, at least, by a comparator, which is provided in the constructor. We've already looked at comparators last lecture, or in a prior lecture. So we have this constructor, and inside the constructor, we can put what the initial capacity would be, and we can pass a comparator object when the priority queue is initially instantiated. So if no comparator is provided, then the priority queue will order its elements according to their natural ordering, which means that all the elements that go into the priority queue would have to also implement the comparable interface to ensure that there is a natural ordering defined on your elements. So in simple words, by default, the priority is based on natural order using comparable, or you can pass a comparator instance that it will then use to compare the objects. So for example, if all elements are the type of integer and no comparator is provided at the time of construction, the natural ordering of your elements will be used to prioritize them, which would be just the normal numerical ordering in ascending order. So the element at the head of the priority queue is going to be your smallest element with respect to the specified ordering, and the element with the smallest value will be assigned the highest priority and removed from the queue first. So if we want a visualization of that, here you can look at the figure where a new element is inserted in the queue, and the priority queue orders the elements according to their natural order. And this happens during insertion. So here, if we look at the front, we have 57, 67, 77, 87, and 97. So 97 is going to be the tail, and the head is going to be 57. So by default, we have everything sorted according to the natural ordering using comparable. So that's in ascending order. When we go to insert a new element, it's going to get inserted in the order based off of its sorting. So we'll insert 65 between 57 and 67. And so then the greatest element will always be at the tail of the queue. So on a typical queue, we would be inserting at the rear. But here, since we're maintaining a sorted order, so as we extract out from the head, we'll constantly be withdrawing the least sized element, which we'll call the highest priority element for this purpose. Yeah, okay. And so removal of elements takes place from the front of the queue. So if we look back at this, this figure that we have here, if multiple elements are tied, okay, so let's look at this first. 57, 65, 67, 77, 87, 97. If we remove an element, we'll remove the 57 from the head. So the new head will become 65. And then if we go and remove the next element, then the next one will be 67. So we remove just like we would in a normal queue. It's the insertions that are different. We don't just insert directly to the rear. We insert in a sorted order. Now, if multiple elements are tied for the highest priority, one of those elements is arbitrarily chosen as the least element. Similarly, when there is a tie among elements at the tail of the priority queue, it's also arbitrarily chosen, right? So if two things are equal, then there's no, it doesn't matter, right? It doesn't matter which one you select, because by definition of how they've been sorted, if they are of equal quality, they're of equal priority. So it doesn't matter which order you select them at. Okay, let's look at the hierarchy of a priority queue. So our priority queue here is a concrete class. It's going to extend the abstract queue class to support a priority-based queue. And so it also implements the queue interface and the serializable interface, but does not implement the clonable interface. And so we'll learn a little bit more what serializable interface means to us when we move to Unit 3 of our lectures. And so this is just a complete hierarchy, right? So the queue interface itself extends the collection interface, which extends the iterable interface. And we've kind of played around with all these interfaces to see what are the abstract methods they give to us, so that when we start to instantiate concrete classes, we understand all of the methods available to each of our data structures. So a quick example class declaration. Now, again, PriorityQueue is a generic class, so it has that parameter typing. So here, public class PriorityQueue, and then we can have a generic data type that it can go ahead and hold. We'll just represent that with E, but that could be any type of object that's stored in the queue. This priority queue extends the abstract queue, which itself, well, not itself, the priority queue also implements serialized. Excellent. So some features of priority queue that are worth mentioning. One, the underlying data structure for implementing a priority queue in Java is a binary heap. Now, I won't go into much detail about what a binary heap, but the modeling components are. I mean, although you could probably take a guess, as there's a reason why priority queues are implemented on top of that concept, but this is a subject domain that you'll be learning about in data structures. The differences between like heaps and trees and graphs and lists. Okay, a priority queue doesn't permit null elements. 3, it does not allow the insertion of non-comparable objects when relying on natural ordering, right? It has to be able to sort. One of the founding concepts, one of the defining principles on a priority queue is that it can prioritize things. So it's important that they're comparable. 4, priority queue is an implementation class for unbounded priority queue, but has an internal capacity that governs the size of the array used to store priority queue elements. So what does this mean? The capacity value is always at least as large as the queue size, and as elements are inserted into your priority queue, it'll internally grow it out. So you can understand, so even though you initially give it a capacity, it can grow beyond that. Just like you'd expect of an array list, for instance. Number 5, the element at the head of the priority queue is the least element, at least with the natural ordering. The element at the tail of the priority queue is the greatest element. So you go from least to greatest. Number 7, the removal of elements always takes place from the front of the queue. The priority queue is not synchronized. So that means it's not thread safe. So when we start talking more about concurrency and multi-threaded applications, almost none of the collections that we've covered would be suitable for those tasks. And we'll talk about what collections you might want to look at, which will be very similar in theory. They just also allow for you to synchronize them. 9, it provides an O of log n time for enqueuing and dequeuing your operations. So again, we won't speak too much about what big O notation is, but what you'll learn in data structures is that's how you can go ahead and evaluate the efficiency of your operations. So when you start doing more code analysis, you can figure out how efficient your code is using big O notation. And so log of n, just so you know, is a very efficient means of removing or adding elements into your data structure, faster than if you were to walk across it for each element. And then 10, the iterator returned by the iterator method does not guarantee that it will traverse elements in their sorted order, right? So you don't want to use the iterator to do that. There's no guarantee that you'll actually get your priority on there. So we'll actually take a look at that in some of our examples. So the priority queue constructors, there's 6 different constructors. We'll kind of look at all 6 of them as an example. So we have the default constructor, which is used to create an empty priority queue with an initial capacity of 11 elements, but keep in mind, it'll naturally grow beyond that as you continually add into it. So here, this is just the general syntax. So priority queue would be the data type. And again, it allows for generic typing. So you'd replace E with whatever the data type is there. And then we give it a label, and then we'll invoke the constructor using the new keyword. And here we could just use the diamond operator even. So because we're always specifying the element there. Okay, the second constructor is we can pass in an int value that represents the initial capacity. So if we want to specify a capacity that's larger than 11 from the get-go, we could do that. And so this constructor would still make an empty priority queue, wouldn't have any elements in there, but it'll have internal array large enough based off of whatever size you pass in there. And of course, the constructor will throw a illegal argument exception if you try to define an initial capacity that's less than 1. We have another constructor, a priority queue, where you can pass in a collection data type. And so this constructor is used to create a priority queue with the specified collection C that's passed in. So very consistent with all the other collection data structures we looked at. There's a constructor that allows you to convert from one collection type to another. So we can take any one of the other collection data types and turn it into a priority queue, provided it meets the minimal requirements for a priority queue. So that means the elements in your collection has to be able to implement the comparable interface. And if it doesn't, then you'll get a class cast exception if they can't be compared in order to perform that priority queue ordering. And also, if for some reason your elements, if you had null elements in your collection, that would also throw an exception because you can't use null elements. You can't insert those in a priority queue. And there's no real way to order those. So that would throw you a null pointer exception. Another constructor worth looking at would be the one where we can pass in a integer value for the initial capacity and then also pass in a comparator object that will be used to define the ordering in the priority queue. And again, in this instance, when the comparator contains a null reference, a natural ordering is used to sort the elements. So this form of constructor also throws an illegal argument exception when the initial capacity is less than 1, just like before. You can't have a capacity smaller than 1 for the internal underlining array. And we also have a priority queue constructor that will take in a priority queue containing the elements in the specified priority queue. So this element, so the elements in the priority queue will be according to the same ordering as the one that was passed into the constructor. It also throws a class cast exception when the priority queue's elements cannot be compared to one another. So this is just a way of building a new priority queue from an old priority queue. And then for the sixth constructor, we can also pass in a sorted set because a priority queue can take since a sorted set has a defined ordering, we can just retranslate that into a queue, our priority queue. So when the sorted set elements can't be compared with one another based off of their ordering, then there's two possible exceptions, just like all the other ones we saw, either a class cast exception, right? If it can't be ordered, or if the sorted set has a null value inside of it, then it will also throw a null pointer exception. So just things to be aware of when constructing a priority queue. So some critical methods that help define the behavior of a priority queue. We have the ability to add an element, which is going to return back a Boolean value on whether it was successful or not. And of course, when we add something into the priority queue is going to insert it based off of its ordering. We have the ability to clear all of the elements out of our priority queue. We have a comparator. So this method returns the comparator used to order the elements of the queue. And so if the queue is sorted according to the natural ordering of its elements, this will be a null object. As recall, there's one of two ways that we can sort or order things based off a comparable and comparator. We have a contains method where we can pass in an element and it will return true or false whether that element is inside our priority queue or not. We can return back an iterator that can be used to iterate over the priority queue, but recall, and we're going to look at this, that the iterator won't necessarily guarantee an iteration based off of priority. So we're going to want to look at the methods that actually are defined within priority queue to be able to do that. So here we also have the offer. So this is used to specify, to add the specified element to priority queue, and this will return true or false on whether it's successfully added. We have the ability to peek into the priority queue. This is a method that retrieves but does not remove that element from the head of the queue. It then returns a null element if the queue is empty. Then you have the ability to poll, and that both retrieves and removes the element at the head. So that actually mutates the state of your queue, and it returns null if the queue is empty. You have the ability to remove an element, and that's going to return back a true or false on whether it successfully removed that element from your priority queue. And then you can check the size of the priority queue. You also have the toArray method, and it takes two different, there's actually two different calls to that. So it returns an array containing all the elements present in the queue. So it either can return an array as an object or at using the generic typing. So you can either get an object-oriented array, or like if this were a generic type of string priority queue, then you can have a string array. And just to show you how all the methods, where all the methods are inherited from in a priority queue, I've included this slide. So you can just kind of see which methods are associated with an abstract queue versus the abstract collection versus the object class versus the collection interface. But I don't want to spend too much time just looking at methods. Let's jump to an example. So here, let's look at an example program that will perform various operations based off of all the methods that we discussed previously on these slides in a priority queue. And in particular, I want to show you priority queue with an iterator, using iterator. So let's actually jump to the IDE so we can actually compile this, but the source code is also included in the slide deck. Let's just wait on my computer to go to the next. Okay. So we have PriorityQueue tester 1 here. So what I'm going to do is I'm going to import the iterator interface. I'm going to import my PriorityQueue concrete class. I'm going to create a new class, PriorityQueue tester, which is going to have a main method. And here I'm going to create a new priority queue. I'm going to use the default constructor. And I'm going to use generic typing to specify that I want a priority queue that will manage string data types. Then I use offer to go ahead and insert new elements into my priority queue. So here I will do a collection of strings: USA, India, England, Germany, and Australia. Then what I'll do is I will go ahead and we will print out the state of our priority queue. And so if we look here, we can see that the state is going to be Australia, England, India, USA, and Germany. And now what I'm going to do is I'm going to iterate over the priority queue using an iterator method. So I'll grab that iterator for strings, and while our iterator has a next element, we will grab that and we will go ahead and just print it out. So again, in the order in which it's currently inside of the priority queue, if we just go ahead and print out the state of our priority queue: Australia, England, India, USA, Germany. The same ordering here. So notice that in the output, when we print the queue, its elements are not ordered right according to their priority, right? Because Germany is last here: Australia, England, India, USA, Germany, right? This is because a queue is never used to iterate over its elements. And so PriorityQueue class does not guarantee any ordering of elements when you use an iterator, right? It's outside of the contract of what an iterator originally agreed to. So therefore, when we print the priority queue, its elements are not according to the, it's not according to their actual priority that we'd expect them to be. So when we use peek or remove, those then the correct element will be peaked or removed from the elements using the elements priority. So this is one of those situations where we're built on top of a data structure. We can't strengthen the contract on iterator, so we have to create new methods that are going to go ahead and do that for us. So let's look at another example here where we'll actually use peek or remove to get the correct element based off of its priority. Okay, and again, let me go over into the IDE so we can go ahead and see this code in action. So inside this example, I'm going to go ahead and import my concrete class PriorityQueue. And actually, let me go ahead and run this so I can talk about the output while I'm going through. And so let's see. Okay. Okay, so here I'm going to import PriorityQueue. Then I'm going to create a new class here, PriorityQueue Tester 2, so I can have a main method. Then here I'm going to create a new PriorityQueue instance. Again, one that will hold strings. So I'm going to use the generic typing to declare that this is a PriorityQueue for strings. And I'm going to use the default constructor to instantiate a new empty PriorityQueue. Then I'm going to use the offer method to go ahead and insert some strings into my PriorityQueue. And here I'll use the same set of strings: USA, India, England, Germany, and Australia. I'm going to print out the state of my PriorityQueue, right? And it's just like it was elements in queue: Australia, England, India, USA, Germany, just like what we did last time. But now what we're going to do is, while we peek into our PriorityQueue and it doesn't return a null reference, which means that there's something that's there. So which is similar to what iterator was doing with has next. So long as we peek in, there's something that's there, we're going to print the head elements. We're going to peek and get the element value and print it out to the console. Then we're going to remove that element, and we'll actually show the element that we removed. And then we're going to show the new state of our PriorityQueue using just printing it out. So initially it was at Australia, England, India, USA, Germany, but we're going to pull out Australia. That's going to be the removed element. So we're inside of the while loop now. And now the new state of our PriorityQueue here. So this is all one execution of the while loop. Then the new state is going to be England, Germany, India, and USA. And the second state of the while loop is going to be these three. So the new head will be England, and the removed element will be England, and the new state will be Germany, USA, and India. And now the next iteration is going to be here. And notice we're going to go ahead and pull out Germany. That's the new head. And so we're removing Germany. And now the new state is going to be India, USA. And so the next iteration is going to pull India out. That's going to be the head element. So that's going to be the one that removed, and that's just leaving the USA. And the last before we remove all the elements will be USA is the head, and then we remove that. And then we have an empty or null PriorityQueue. So notice the actual ordering: Australia, England, Germany, India, USA is the appropriate ordering based off of priority using this queue. So again, the trick here is that you have to use peek and remove to be able to get the order you'd expect. Okay, let's look at another example of a program where we can use comparable and comparator for priority. It's just to illustrate that we can use either of those. So I want to jump back on over to my IDE. Here we go. And let's run this. Excellent. And it's down some. Okay. So in this instance, I want to go ahead and import the collections interface. I want to go ahead and also import my PriorityQueue, my concrete class, so I can build or instantiate a PriorityQueue. We're going to create a class PriorityQueue Tester 3. We're going to make a main method. Inside our main method, we're going to create a new PriorityQueue instance variable, and we're going to instantiate using the default constructor. And again, we're going to use the static typing to go ahead and hold data of type integer. So then we're going to offer up some data. We're going to insert some data into our priority queue using offers. Here it'll be 50, 100, 60, 20, and 10. So again, that should, using the natural ordering, will be in ascending order. So from least to greatest. And what we'll do here is the priority queue using comparable, what integer naturally goes ahead and implements that interface. Then we'll say, well, so long as the size, this is another way that we can make our while loop, so long as the size of our priority queue is greater than 0, that means that there's elements in there, then we'll remove that element and we will print it out and then add a empty space behind it so that we can just print them all out one after the other from left to right. And so if we look at that, we can see here, we're printing the queue using comparable, and the results of this while loop on line 16 is going to be here. So we added 10, 20, 50, 60, and 100, and that's the order, and we're going to get 10, 20, 50, 60, 100. So we put it in a random ordering, but we're going to get it in the order from least to greatest. And then the size is going to be here. Okay, so the next thing we're going to do after printing using comparable is we're going to create a whole nother priority queue. But here, we're going to use not the default constructor, but the constructor where we can pass in a comparator instance. So recall that when we use that constructor, we also have to specify what the initial capacity is. So the first parameter is the initial capacity. We'll just put 5. And then the second is from the collections class. There's actually a helper method. There's a static method inside the collections class, reverse order, that will return an iterator that will sort things using a descending order as opposed to an ascending order. So it will reverse the order of whatever the natural ordering is. And so then we're going to offer up the same set of elements of those integers into the second priority queue. We'll get the size of our priority queue. We'll print it out just to illustrate what the underlying size is. And then what we'll do is we'll do the same while loop, doing the same remove method. But what you're going to see is the result's going to be different because we're using a comparator that's using the descending ordering. So here you could see that the return values are going to be 100, 60, 50, 20, and 10. Excellent. And that's everything that I have to say about priority queues. And this ties nicely into illustrating that priority queue is like it's like a queue, but it doesn't follow the behavior of a queue, right? Because a queue has they both have specific orderings of how things are inserted and extracted. But one is uses when it's inserted as its sorted mechanism, where this uses a natural ordering for sorting. But you'll probably encounter priority queues when you hit OS. So it's something that's definitely worth looking into and kind of understanding what's happening behind the scenes. And you'll likely do a little bit more examination into these data structures, these data containers, these collections when you hit data structures. Is there any questions related to priority queues?